Okay, it's Wednesday, 20th of May 2020, afternoon. Time for physics. Um, so this time we get a formula sheet. Actually, technically we had formula sheets for the previous, for maths and statistics. I don't think I ever looked at them. This one I probably should look at. Okay, so, all right. So paper, okay, so this is the sheet. So what do we got here? Pressure due to a column of... Wow, I don't remember that stuff, but whatever. We've got the formula now, so... Um, oh, these are the distance acceleration equations. Okay, fine. We got Newton's second law, kind of. We got elastic potential, change... Magnification. Okay. Force on a conductor at right angles to a magnetic field carrying it. Okay. I mean, as long as we have the formula, we can try to work out how it gets used. Differences across primary coil. God. Oh man, this stuff, electromagnetism, was this done in GCSE? It probably was. Wow. I don't remember electromagnetism. PV equals constant. So you don't do like electronics, like V equals IR, stuff like that? Oh, higher. No, well, I am doing higher TS. So. Okay then. Well, let's begin. Okay, so we've got Mr. Tree. Uh, so we need a ruler? I don't have a ruler. Um, I can draw reasonably straight, maybe. All right, so a scientific calculator, yeah, we'll just use Google for that. And then we've got this physics equations sheet. And we've got 1 hour 45. All right. Okay. Oh yeah, just before I start, this is a reminder of my grades so far. So I got top grades for maths, statistics, and computer science, but those are my three best topics. Physics, I've decided to predict 9, top grade, so I'm worried now about all this electromagnetism stuff. Okay, we'll see. So, we begin? Right, a student investigated how the current in a filament lamp varied with a potential difference across the filament lamp. Complete figure 1 by adding an ammeter and a voltmeter. Use the correct circuit symbols. Okay. So I think you put an ammeter, I don't know, it can go anywhere. Let's put it here. I think it's just an A, isn't it? And a voltmeter. What are we measuring again? So you would put it across the lamp. like that. Those are symbols? I think so. 3 marks! Yeah, okay. Figure 2 shows some of the results. Student reverse the connections to the power supply and obtain negative values for the current and potential difference. Draw a line on figure 2 to show the relationship between the negative values of current and potential difference. Would it just be negative? So the amperes will go negative, but the potential difference, is it always a positive number? Is it just the difference between the higher and the lower? No. No, of course you can have minus 5 volts. Okay, so it would just be the mirror, not mirror, just be like this, wouldn't it? So it would go to, so I probably have to put the crosses like roughly there. 6 volts, we get about there. So it would probably be like this, unless I'm missing something. Just pretend that was a better drawn line, because it's the best I can do. Write down the equation which links current, potential difference, and oh, I know this one. Determine the resistance of the filament lamp when the potential difference across it is 1 volt. So that's why this is not in the formula booklet, because you're supposed to know this off by heart. Alright, determine the resistance. Alright, so this is a filament lamp when the potential difference is 1 volt. So we just want... So 1 volt gives us... Uh, 0.8. 0.08. Is that amps or milliamps? Normally it's... Oh, okay, it's amps. Right. So R equals V over I equals 1 over 0.08. Okay. I mean, that would be 100 over 8 equals 12.5. Excuse me. The ammeter used had a 0 error. Guaranteed to be correct? What? Guaranteed. Zero error to reflect the exact current without tolerance. Actually, I don't know exactly what they mean by 0 error here. LED torch. Torch contains one LED, one switch, and 3 cells. Which diagram shows the correct circuit for the torch? So it's not that, because the cell is the wrong way around. I think the positive side should be this side, and the negative side should be this side. So I think it's this. Write down the equation which links. Oh, it's nice of them to give it in the right order, isn't it? Q equals IT. They even gave it in the order in the question. Okay, we'll say lower t. The torch worked for 14. Okay, so we've got T equals 14,400. Current. I should start writing my I's like this. Equals 0.05. Oops. Calculate the total charge. So Q equals 14,400 times 0.05 equals 14. 720. I mean, that was easy to work out arithmetically. All right, so 720 coulombs. When replaced, the cells were put into the torch the wrong way around. Explain why the torch did not work. LEDs can only be used. Only allow charge. I mean, this is a simplification. Well, it's pretty much true, isn't it? LEDs only allow charge in one direction. With cells the wrong way, no current will pass through. Therefore, no charge. Because Q equals IT. I don't know, just say random stuff. Write down the equation which links efficiency, total power input, and useful power output. Efficiency equals use. I mean, it can only be this, right? You don't even need to know physics to know this. Power divided by total power. The total power input to the LED was 0.24 watts. The efficiency of the LED was 0.275. Calculate the useful. Okay, so useful equals 0.75 times 0.24 watts equals 0.8. Alright, this is easy so far. Electricity is generated water for the reservoir flows down through the turbines. Okay, write down the equation which links density, mass, and volume. Rho equals mass divided by volume, right? Yeah, I don't know why I paused there. Okay, the reservoir stores blah blah blah. Density of the water blah blah. Okay, so we want the mass. So mass equals rho v equals 998 times 6,500 3. This is pretty straightforward. Equals 998 times 6,500. 998 times 6,500. 1, 2, 3. 6. Okay, we need standard form. Hang on, let's. 6487. 6487. And 6 zeros. So let's say 6.487 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Kilograms. Straightforward enough. Write down the equation which links energy transferred, power. Wait, let me just make sure this is higher tier, right? Not that I'm complaining or anything, it's okay. It might get harder later on. Energy transferred, power, and time. Okay, power is in watts. Watts, and I remember the old joke. Watt is a joule per second. Like, as if it's you're asking the question, what is a joule per second? And the answer is watt. It's physics humor. That's the joke. So, energy divided by time. Or, should we just say or energy equals PT? I don't think it matters which way around you. All right. The electrical generators can provide 1.5 power. All right. All right, this reminds me, have we always been converting to standard units? So we've got kilograms, meters, that's fine. We've got watts, amps, so I converted to amps, that's correct. Coulombs. Yeah. Volts. So on this, for this question, we actually need to be careful. So first, we need to convert 5 hours equals 300 minutes equals 18,000 seconds, is that right? Yes. Okay, so it needs to be in seconds. So energy equals PT equals 1.5 times 10 to the 9 times 18,000. Equals, we just don't have to type that all into the calculator. We can say like that. Okay, 1.5 times 18 is 27 times 10 to the 12, so 2.7 times 10 to the 13. So they don't want like kilojoules, megajoules, whatever. That's... Is that too much? Is that... maybe that's right. What unit of energy is normally used? Kilojoules, right? But that's a lot of kilojoules. Let me go through this calculation again. 5 hours, 300 minutes, 18,000 seconds. Okay. Energy equals power times time. Equals 5 times 10 to the 9. I mean, that's a lot of watts. So I guess it makes sense. Okay. UK demand for electricity increases and decreases during one day. So we get the most at like 6 o'clock when people will wake up. When some crazy people wake up. And then decrease from 8 p.m. to like midnight. Right. Two points. $1.5 times 10 to the 9. So four. Hang on. 1.5 times 10 to the 9. 1.5 is right at the bottom of the chart here. Wait, it's off the chart. $1.5. So, am I missing something? It's way off the chart. It's not even on the graph. That's... from 4, between 4 and 4. So... I mean, this graph isn't even useful because it's just so high. Okay, should I just say the demand at all at all times is higher than 1.5 times 10 to the 9 watts, and the time interval required is 10 hours more. No, 12. This is wrong. More than 5. This is a weird question. 1.5. Is it? It would have made more sense if it was 15. I don't know. How much electricity was generated using coal-fired and gas-fired power stations in January for 5 years in the UK? So lots of delicious coal, not much gas, and then more gas and less coal. Still using a lot of coal. This is only a couple of years ago, well, 4 years ago. Determine the percentage increase in electricity generated using gas-fired power stations from 2014 to 2018. Okay. So 2014, it's what? 3,200? 2018, 10,000. So 10,000 over 3,200 times 100 equals 10,000 divided by 32. We want 2.5. So basically multiplied it by 3 on 2.5%. Yeah, it's like timesing by 3. Okay. Give 2 environmental advantages of using gas, then less. It's always going to be less pollution, isn't it? Let's be specific. Air pollution. To I don't know. Air pollution is one of the biggest concerns, isn't it? What else? Well, when you're extracting coal, less physical damage to. How do I express this? Less geological damage caused by mining coal. Is that true? Yeah. But I don't know. The mean surface temperature of the sea changes throughout the year. A change in the mean surface temperature from year to year indicates climate change. Mean surface 1988 to 2016. The student does not believe that climate change is occurring. Explain how the data in figure 7 suggests that the student is wrong. There is a notable... Hang on, should I just use the text box for this? There is a notable increase in average temperature over the years from about 16.45 to 16.95, an increase of around 0.5 degrees. This indicates that climate change is taking place. What else can you say? The thermistor can be used to measure temperature. Resistance of 4 different thermistors varies with temperature. Which of the 4 thermistors would be the most suitable to measure the surface temperature of the sea? What is our goal with thermistor? We want the rate of change to be best around the temperature we're measuring, don't we? So if we're measuring at 16.5, 16 to 17, so 16 to 17 is about here. I would say C. Okay. Around 16 to 17 degrees C, the expected temperature of the sea. The Mr. C has the steepest gradient, so would be most sensitive to slight changes in temperature that can be recorded. D is unsuitable as its resistance is too high in that range. Radioactive waste from nuclear power stations is a man-made source of background radiation. Give one other man-made source of background radiation. Background radiation. Well, coal actually produces radioactive radiation, doesn't it? Man-made source of background radiation. Bombs? Are they counting that? That's pretty significant in certain areas in the world. Nuclear, I don't know much about this stuff. Nuclear is a very strong factor, but I imagine even coal and stuff produces a bit of background radiation. Maybe it's too maybe it's insignificant. What else? I don't actually really know. Coal? Should I just say coal? Or are they, if I say nuclear weaponry? I mean, nuclear weaponry is correct. It should be correct. Give the name of one nuclear fuel. Fuel? I don't know what is meant by fuel. Uranium? Is that the fuel? I suppose it is. Yeah. It's the product which undergoes a process to produce energy. Uranium 235, 238. I don't know. I'm just quoting stuff I've seen on Factorio. Nuclear fission releases energy. Describe the process of nuclear fission inside a nuclear reactor. Oh my god, I don't know anything about this. Fusion. Nuclear fission. Nuclear fusion. Fission. Is it what happens in Factorio? Or is that fusion? What? Okay. What happens in Factorio? This is where I actually use my gaming knowledge. Yeah. Okay, so in Factorio you have uranium 235 and uranium 238. What happens? You release protons? I don't know. Oh man, I could end up writing something completely stupid. So fusion is fusion is involving hydrogen, isn't it? Also fission. Okay, let's just say what happens in Factorio, I don't know. Uranium is used as a fuel in the form. Why am I using? Let's use a text box. This, oh man, I'm gonna be really embarrassed if this is just completely and utterly wrong. Uranium is used as a fuel in the form of rods. The uranium rods are inserted in water? Is that even true? I don't know. Fission results in the uranium decaying, losing neutrons? It's not protons, it's neutrons, right? Which releases huge amounts of energy via E equals mc squared. Let's just tell the examiner we know E equals mc squared. Does that give us points? The energy is released in the form of heat, which heats the water and creates. I'm literally just typing out what I remember from Factorio. Creates steam, which drives steam turbines to be harnessed as electricity. To harness electricity. How do you do the fission though? What are you actually doing? I don't know. Charge? Using charge? What do you do in Factorio? You put it in you put it in a reactor. I didn't say the word reactor. A reactor is used to induce fission. I don't know. But what do you actually do in the reactor? You add another. That's enough for now. I don't know. A new type of power station is being developed that will generate electricity using nuclear fusion. Oh no, not fusion. I know even less about fusion because I don't think that is used in Factorio. Is that where you combine hydrogen atoms to produce hydrogen atoms are combined and fused to produce what? Heavy hydrogen? Is that a thing? Why do I remember that? Am I thinking of something else? No, this. But hydrogen has to have one proton, doesn't it? So. Okay, this. Protons are released? Produce energy. This is probably even worse. More stupid. nuclear fusion power stations, waste will have a much shorter half-life. Alright, I am definitely losing marks here, lots of marks. Shorter half-life means a shorter time required for a fixed amount of mass to decay. This means that less long-term storage is required, and waste need be stored for a shorter time, which costs less effort and space. I don't know. Okay, thank you. No more nuclear stuff. A light gate and data logger can be used to determine the speed of each rider and sled. What two measurements are needed to determine the speed of a rider and sled? Okay, time for sled to pass light gate, length of sled. Not mass, as was it Galileo showed that mass is independent. Gravitational field strength is fixed. Temperature of surroundings is irrelevant. Unless it's like on fire. Okay. The decrease in gravitational potential energy of one rider on the slide was 8.33 kilojoules. The rider moved through a vertical height of 17 meters. Field strength in newtons, calculating the mass of the rider. So we need to work out the force. Let's have a look at our formula booklet. Does it have anything important here? Change, no time taken. No. So got energy, got force per so we've got field strength, which is like force per kilogram. So to find kilograms, we need to find the force. All right, fine. Work, I remember this now. Work done. Done equals force times dist. So force equals work done over dist equals 8.33 kilojoules over 17. Meters equals, so 8330 divided by 17. 8330 divided by 17 is 490. All right, that's looking good. 490 newtons. So mass equals G field strength divided by 490 equals 9.8 divided by 490. divided by 490, 0.02 kilograms. That can't be right. No, wait. What am I doing? 490 divided by 9.8. Oh god. 50. That sounds about right. That's like a lot less mass than me, but okay. At the bottom of the slide, all riders and their sleds have approximately the same speed. Explain why. Bottom of the slide, all riders and their sleds have approximately the same speed. Because, okay, how do we say this with 4 marks? Because mass doesn't matter, right? So let's have a look at our formula booklet again. Do we have any? We've got final velocity minus initial velocity. V squared minus u squared equals 2as. That might be useful. V squared minus u squared equals 2as. V squared minus u squared equals 2as. So v squared equals u squared. U equals 0 because they start stationary. Plus 2as. 9.8 constant. So v squared equals 2.6 s. S is fixed. Therefore, V. Okay, let's explain this in words. V, final velocity, depends only on initial velocity, in this case 0, acceleration fixed across a surface, and distance constant for all riders according to the derived equation. The final speed is unaffected by mass. What else can we say? So should be the same for all riders. An electric kettle was switched on. Figure 10 shows that the temperature of the water inside the kettle changed. When the kettle was switched on, the temperature of the water did not immediately start to increase. Suggest one reason why. Kettle was switched on. Suggest one reason why. Because heat was being transferred between the materials. In the kettle. The heating now getting into gaming again. So this is oxygen not included. So if you use a highly thermally reactive, like the heating filament, and takes some time to heat up the filament before heat gets transferred to the water. What is it? Newton's... No, not Newton. Via the laws of thermodynamics. I don't know which one. Probably the first one. I bet that's not the answer. I bet there's something even simpler. Alright, the energy transferred to the water in 100 seconds was... Show the mass of water in the kettle. Heat capacity of water. Why is it 5 marks? What the heck? Let me have a look at this formula booklet. I think this was here. Here we are. Change in thermal energy equals mass times specific heat capacity times temperature change. Change in thermal. So delta E. So we've got delta E equals mass times capacity times delta temperature. Delta mass times C times delta. Okay. So mass equals C delta theta over delta E. So C equals 4200 J kilograms minus 1. Delta theta equals, so we go from 22 equals 100 minus 22 equals 78 degrees. 78. You're supposed to use Kelvin, aren't you? Not that it matters. I mean, it's linearly equivalent, so we can say C, but it's and delta E equals 155,000 joules. So we do M equals 4200 times 78 over 55123. 5 marks. Like 1400 times 78. This might just be an easy 5 marks then. I didn't even know any of this stuff, but I'm just working it out from the formula in the booklet. 155,123. 2.11 mass of water equals, okay, equals 2.113, 2.113, so 2.1 kilograms. That sounds about right for, what was it? Kettle. It's like 2 liters. Okay. The straight section of the line can be used to calculate the useful power output of the kettle. So useful equals so what was it again? Useful efficiency. Okay, so efficiency equals useful out of input. Useful power output. So useful equals efficiency times input. What? So let's pick some points here. So let's say I want to find the gradient basically. So I want to say this point here. So that's 80 and that's 85. Let's say here 50. That is 55. So we've got 30 seconds, 30 C. So it's 1. Gradient equals. Wait, kettles are 100% efficient, aren't they? How can they not be? Oh, but we're not finding the efficiency. But we know it's 100, isn't it? So hang on, so it's gradient equals 1 C per S. So okay, and this is where we use this formula. Heat capacity. So we got delta E equals MC delta theta. So now we're tapering off. We're getting rid of the fuzzy bits on the line. So we got delta E equals mc delta theta. So that is 30. That is 4,200 joules per kilogram. Joules per kilogram degree C. Yeah. 4,200. Mass is 2.1. This equals 2.1 times 4,200 times 30 equals I still don't understand where I'm going with this. 2.1 times 4,200. 2.1 times 4,200 times 30. 264,600. So 264,600. So that's the change in energy. Joules. So that is the. I don't understand. What does that give us? That tells us the energy transferred to the water, change in thermal energy. Useful power output. Oh, and divide that by time. This has nothing to do with efficiency. This is power. Power equals energy over delta T equals 264,600 divided by 30 seconds equals 264,600 divided by 30 equals 8820. 8820 watts equals 8.82 kilowatts. That sounds about, yeah, sounds plausible. Useful power output. So that's when it's at its best, like it's heated up, there's no loss of energy in the materials. Okay. Explain how. Explain how. Am I not supposed to calculate it? Have I done something? Should I just say the straight bit represents most efficient increase over time? All right, enough. Student investigated how the total resistance of identical resistors connected in parallel varied with the number of resistors. The student used an ohmmeter to measure the total resistance of the resistors. So this is the harmonic sum, isn't it? The student repeated each reading of resistance 3 times. Table 1 shows some of the results for 3 resistors in parallel. Calculate value x. Okay, so 15.8 plus 15.3 plus x over 3 equals 15.7. So x equals 15.7 times 3. Take away 15.8, take away 15.3. 15.7 times 3. 15.7 times 3. Take away 15.8. Take away 15.3. 16. Does that sound right? Yeah. Students thought that taking a fourth reading would improve the precision of the results. The fourth reading was 16.2 ohms. Explain why the student was wrong. Precision of the results. Well, it would improve the accuracy. It would improve accuracy, not precision. Precision would be defined by the ohmmeter. Meet 2 ohms used. Yeah. Is that what they're getting at? Accuracy, not precision. And precision. I don't know. Also, wouldn't doing it often heat it up a bit more? Would that change something? Change resistance? Resistance increases with heat, doesn't it? Or the other way around? Why did light bulbs work? No, it decreases resistance, doesn't it? I don't think that's what they meant. Okay. 12. The student concluded that the number of resistors in power was inversely proportional to the mean total resistance. Explain why the student was correct. Well, that is correct, isn't it? The harmonic series. Harmonic sum. Using data from figure 12. Oh, okay, for using the data. Well, all right. The data follows a 1 over x trend, e.g. for 3 r equals 16 for 6 r equals 8. when doubling the num of resistors, the resistance halves. Just put some dots there to show that we've actually done something. Okay. Explain why adding resistors in parallel decreases the total resistance. Because the potential difference stays fixed across each. Oh my god. Oh, why don't. Okay. The potential difference remains fixed across each pair. Let's look at the circuit again. And equal to the voltage across the ohmmeter. The current is split evenly between the branches since the resistance of each branch is equal. Therefore, using V equals IR, i.e. R equals V over I, we can see that increasing num of resistors would divide the current evenly but keep V fixed. Therefore, resistance would Wait, I'm talking complete nonsense. This is not what they're asking. Oh, God, hold on. I don't know. I don't really know the actual answer for why he does this. It's just, hang on. The general understanding is that you have more ways to get to your destination. Therefore, how do you say that in a more rigorous scientific way? No, hang on. Okay. Potential difference is fixed. That's true. Current is not quite what I said. So okay, the total current increase resistors because they're. I don't. I know what I know what how it works in my head, but I can't put it into words. The more. Because it is the sum of currents across individual resistors, which is fixed, since V and R are fixed for one resistor. Since overall R equals VOI, current being multiplied by a factor would result in resistance going down by that factor. That's essentially the current has more avenues to follow to reach the destination. So it is, I'm talking nonsense now, easier, and resistance is lower. It's 2 marks, I don't know. Which was part of a mains electricity lighting circuit in a house. The fault in the live wire. Fault in the switch caused a householder to receive a mild electric shock before a safety device switched the circuit off. I see. Well, this is interesting. All right, so we've got a person. They have essentially touched the live wire, and they're standing on the ground, so they're essentially sort of touching earth. So this is the complete circuit. But is the switch closed? The mean power transfer to the person was... Okay. P, what is it? P equals IV. No. Yeah, P equals IV. I equals P over V equals 5.75 watts over 230 volts equals 5.75. So is the lamp relevant? No, the switch is not closed. 5.75 divided by 230. 5.75 divided by 230. 0.025. 0.025 amps. Resistance equals V over I equals 230 over... Oh, so it's P equals I squared R, isn't it? It's actually Oh, no, it's like, what was IV? P equals V squared over R. Anyway, we're going to get there. So 230 divided by 0.025 amps equals 230 divided by 0.025. 230 divided by 0.025. 9,200. 9,200 ohms. It's like V equals I squared R or something. No. Not P equals... There is another formula you can use, which is... It would be... I equals V over R, so... It would be P equals V squared over R, like that. So 230 squared divided by 5.75. 230 squared. 230 squared divided by 5.75. 9,200. Same. Okay. An electrician replaced the switch. The electrician would have received an electric shock unless the circuit was disconnected from the main supply. Isn't that obvious? If the main supply is connected, the electrician touching the switch completes the circuit using himself as a resistor. So he would, I mean, this part is already made clear from the shock as the previous person did. If main supply is disconnected, there is no current flowing when he completes the circuit. Therefore, no voltage cross. Why is this 3 marks? Since his innate resistance is fixed. I don't know. Okay. The current from an electric shock causes a person's muscles to contract. The person cannot let go of the electric circuit if the current is too high. The maximum current at which a person can let go depends on the frequency of the electricity supply. The UK mains frequency is 50 Hertz. 50 Hertz gives, use the text box here. Hertz gives the minimum value for max current at which person can let go according to the graph. Any other frequency above or below 50 results in a higher max current value, therefore higher chances that a person would not have enough current to make them unable to let go. Fewer injuries and deaths. Movement of the gas particles in the balloon. Shows a balloon filled with helium gas. Which statements describe the movement of the gas particles in the balloon? Random directions, that's for sure. Particles move at the same speed. Circle paths. Range of speeds. Particles, yeah, those two. Pressure of the helium in the balloon is 100,000 pascals. The volume of the balloon is that. Balloon is compressed. No helium. Pressure, volume. I don't remember how to do what do we do? Pressure. Gases. Pressure times volume equals constant. PV equals constant. So we've got 100,000. Let's call it K times 0.03 meters cubed equals 100,000. It's 3,000. So K equals 3,000. So P V equals K implies that P times 0.025 equals 3,000. So P equals 3,000 over 0.025. 3,000 over 0.025. 3,000 over 0.025. 120,000. 120,000. Does that sound right? So you've decreased the volume by a bit. Pressure goes up by a bit. Yep. Temperature of the helium in the balloon was increased. Hang on. Excuse me. Goodness. Okay, well this is text. Let's make a text box. All right. Mass and the volume of helium in the balloon remain constant. Increasing temperature would transfer thermal energy to the helium molecules. This would raise their energy levels, increasing their movement speed overall. Higher particle speed results in greater force exerted upon the balloon walls when they collide. Which causes increased pressure. Shall I mention Brownian motion? As they undergo Brownian motion. Higher particle speed results in greater force. Is that true? Yeah. Greater force exerted. Greater change in momentum via Newton's second law. We're getting everything in there. That's it. We've got like 12 minutes left. I don't think I want to look over my answers. I'm pretty happy with everything except for the nuclear power ones. Maybe one or two places I'm not that happy with. Yeah, all the calculation questions I'm pretty happy with. Just have a quick scan. That looks like nonsense, what I just said there about hydrogen atoms. I don't know. I might get some marks. Undersled. Yep, this is all good stuff. I think I'll get good marks. I'll just lose maybe 10 marks, or maybe 6 to 8 marks I'll lose on those ones I just don't understand, like nuclear power. We didn't study that in school. Pretty sure we didn't. It's pronounced nuclear. Oh, that's the Spanish version. It's pronounced nuclear. Yeah, I just want to finish there then. Mm-hmm. All right then. Stop. Okay. All right, let's grade this thing. All right, so question 1. What is all this? Make marking of lists, whatever. Okay, Symbols. What are the symbols? Okay, I think I got them right. So, voltmeter in parallel, ammeter in series. Yeah. So. Yep. Okay. Question 2. Yep, we did that. Passing through. -4, -0.2, -4, -0.2. Yeah, it does. I mean, just slightly off, but I mean, I did say, you know, if I had a piece of paper, I would be able to do it smoothly and copy all those points. Yep, that's fine. All right, 3, B equals IR, then 12.5. Oops. Yep, 4 marks, nice. Ammeter displays a reading when not connected. Oh my god, that's what it means. Yeah, that what I wrote was nonsense. I'm sure they could come up with a better name for that. They've lost a mark there. Oh, I see. Because the ammeter uses power to even display the thing on a 7-segment display. Unless you give it its own battery, then it doesn't have to. Is that what they mean? Okay, so yep, that's right. Plus, negative is on the flat side. Q equals IT. 720. There is no current in a diode in the reverse direction. That's, yeah. When cells are in, no current will pass through. Yeah, that's what I said. 2 marks. Oh, you need to say the resistance. Because it's not technically infinite, is it? It's just very, very high. So current can go through in the opposite direction. It just has a very high resistance. So the graph looks like... What does it look like? I don't know. I don't know. But yeah, I lost a mark there. Useful over total. Yep. 0.18. Yep. P equals M over V. 6.487 times 10 to the 9. Yeah, see, these calculations are easy. And I'm doing this not remembering any of this stuff because they give you the formulae, or it's in the book, and you just solve them by, what's it called? Dimension analysis. Dimensional analysis is a great tool. You just analyze the dimensions of what you're given and you can work out from there what you're supposed to have. Just because the units have to make sense. Okay, P equals PT. Yeah, I said that. Do they not give a mark for P equals E over T? I don't know, but I wrote E equals PT. Right, 2.7 times 10 to the 13, yep. The variation in demand is greater than 1.5. Demand remains high for longer than 5 hours. Okay, I definitely said that second part. The variation in demand. Why is it the increase and not just the demand? I don't understand. the increase in demand is greater than the increase in demand from 4 to... So what, this distance here? I didn't actually say that, but well, I don't understand. Oh, but the question said increase in demand. Oh, I get it now. They're not saying the hydroelectric powers it all day. They're saying something else powers it most of the day. But for 4 to 4, they want to bring in the hydroelectric to account for the higher demand. So it's extra. So it's the increase that matters. Okay, fair enough. So I got 1 mark because I did mention that the time is longer than 5 hours. But I didn't pay attention to this word here, increase. Fine. 312.5. Percentage increase. Oh yeah, but that's ambiguous because... So you have to take away the original 100%. I mean, that is... now that I think about it, that is the most sensible way to describe increase. But I've definitely seen it described the way I've written in many scenarios, so it's actually kind of ambiguous. Alright, what can I got the answer wrong, but the method was right. 10,000 minus... So I just didn't put the minus 3,200 there. I think I get 1 mark, but because but I've done it kind of the other way around from what they've done. I didn't subtract the 100 after. But my formula is correct for percentage ratio. So I think that's worth 1 mark, but it's hard to tell because sometimes it's fine as long as what you're saying is equivalent to what the marking scheme says. Sometimes you actually have to have what the marking scheme says. But no, what I've just said is another way of doing it. You find the percentage ratio and then take away the 100 to get the percentage increase. So yeah, 1 mark, I think. Oh dear. Less air pollution. Ignore less air pollution. Are you serious? Gas mining is less destructive than coal mining. Okay, yes, I got that mark. But they say ignore less air pollution. Why? Because they want us to specifically say sulfur dioxide or carbon dioxide. Why didn't I say carbon dioxide? It was such an obvious thing to say. Fine, I got 1 mark. I was about to write it, but then I thought air pollution is... I mean, it's correct. It's the correct answer. What? That's just... That's... I mean, most marks that they're taken from me, I can accept. But this one, I mean, I literally wrote a correct answer. Well, why don't I get a mark for it? Notable increase in average temperature over the years from the 16.45 to 16.9. Yes. Yes, over the time period of the graph. Yeah, that's fine. C, please C, please C. Yes, because the change of resistance is greater. Yes, correct. Nuclear weaponry and bombs. Yes, yes, yes. Nuclear weapons. Uranium, yeah. Oh god, here we go. Neutron absorbed by uranium nucleus. Oh, it's the other way around. I thought it splits. I thought it loses neutrons. So you fire neutrons at the uranium. Ugh. Whoa, 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 hang on. Nucleus splits into 2 parts. Okay, I didn't say neutron absorbed. I didn't say nucleus splits. I did say neutrons are released. And gamma rays are emitted. I didn't mention gamma rays. Yeah, I wasn't talking about what happens in the reactor. So I was going off topic there. But I did say neutrons are released. So I got 1. I have no idea. I don't know about this. Alright, so I lost 3 marks there. Hydrogen atoms? Is this lighter nuclei join to form heavier nuclei? Some of the mass of the nuclei is converted to energy. Ooh, I got this all wrong. But half right. But it was half right uniformly, so it's wrong everywhere, really. You don't add hydrogen and hydrogen to get hydrogen. You add hydrogen and hydrogen to get like helium or something, don't you? And you don't release protons. What is this? A01 4.4.2. Is this in this booklet? Am I supposed to... I don't know what this is. Alright, let's look this up. Google this. Because I don't know if what I said is even remotely true. So, fusion. Examples. Hydrogen nuclei fuse to form helium. Why didn't I say helium? You don't release protons, and you don't produce heavy hydrogen. What is heavy hydrogen? Is that even a thing? Deuterium. That's an isotope. You don't, that's a different thing I was thinking of. You don't use deuterium. It's not a byproduct of fusion. Is it? In the process. The easiest fusion reaction is combining deuterium, heavy hydrogen, with heavy hydrogen to make helium and a neutron. Yeah, I got it all wrong. Oh my god. Activity decreases quickly. Decay at a greater rate. That's what I said. Burial site doesn't need to be monitored for as long. Or doesn't need to be, may not to be buried underground. That's basically what I said, isn't it? Costs less effort and space. Waste need to be stored for a shorter time. Okay. I think that's within reason. Alright. Length of sled, time to pass gate. 50 kilograms. Final speed only depends on vertical height and gravitational field strength. Yeah. Yeah. I've said this. Hang on. Half mv squared equals mgh, or decrease. Half mv squared. Well, that's not the formula I used. 2 mgh. No, that is the formula I used. The 2 goes over there. The u squared cancels out. A is force divided. Yeah, this is the same formula. Okay, masses cancel on both sides of the equation, or v squared equals 2gh. Yes, I wrote that. V squared equals 2gh, 2as, which is g, acceleration. Variations will be due to air resistance, friction, or... Oh, well, they didn't ask about the variations. You have to give them even what they don't ask for. You've lost 11 marks, that's bad. Yeah, I didn't... Approximately. You have to account, you have to say why there would be variations as well. Alright. Heating element of the filament? Element? Is that the same thing? Yeah. 2.1. What the heck? 0.47? What have I done wrong here? E equals mc times 78. Yes, so I did that. 78, so I got 2 marks so far. M equals 155,000. I got this upside down. 2 kilograms is quite a lot, isn't it? Damn it. So I basically got that upside down, so everything else was correct if I followed through. So 4 marks. Straight bit represents most efficient increases over time. Gradient equals that change in temperature per time. I did say that here. PT equals MC. Yep, I've got that formula. Gradient times MC. It says allow calculation of gradient, which I did. Power equals gradient. And that's implied because I then did energy divided by time. I think that's correct. It just looks very different to what the marking scheme says, but it's all in there. 16 ohms. You would improve accuracy. What? Oh, I see. see what they mean. What I said was... Damn it. No, I was thinking completely wrong thing. It's actually increased the range. So the variance has increased, therefore precision has decreased. But the student, it's a bit confusing because the student wasn't wrong. Well, he was wrong in thinking it would unequivocally improve the precision. But he was neither wrong nor right. He was wrong. But it wouldn't decrease it either. It just is irrelevant. Ugh. Okay. Two pairs of showing that. Two pairs of values of n and r. So I did 3 and 16. Okay, yeah, I did that. Third pair of values of n and r showing the n of... Why do you need a third pair? Why not a fourth and a fifth? Like, why isn't 2 enough? Alright, I got 2 marks there. Apparently you were supposed to try 3 different values. It doesn't tell you how much. Oh my god, I'm losing marks. Crazy. Multiple paths. Oh wow, I actually said that. More avenues to follow. Total current is greater for the same potential difference. Yes, I did say all that. In a really long-winded way. 9,200, yes. I didn't understand what it was asking. So they're asking why he would receive a shock. I thought they were focusing on why he wouldn't when the main supply was removed. So ignore the second paragraph. First paragraph I said, touching the switch completes the circuit using himself as a resistor. Damn it. I didn't... You never know what they want. Okay. I got 0 marks here. That was terrible. I just said something completely different. Which was technically correct, but... It looks like they're asking why is it important that he... It looks like they're more interested in what would happen if it's disconnected from the main supply. It's like they're saying, okay, it's a given that he would receive an electric shock, but why would he not get one if the main supply is removed? That's how I interpreted the question. I've lost so many marks. 50 Hz gives the lowest electrical current, higher will allow people to let go at a greater current. Yeah. Random directions, range of speeds. Yep. 120,000. Higher. Yes, mean speed, yes. So increased number of collisions, yes. Greater forces exerted in collisions. Greater force exerted on same air. Same. What do they mean by same area? Because it wouldn't be. Well, it would. Let's see. I got the first mark. Wait, hang on. Did I mention frequency? Reason increase in movement speed over higher particles with greater force exerted on the balls. I definitely got 1 and 3. I don't think I even mentioned 2 and 4. Yeah, I don't know how much they want me to mention. Increased number of collisions with the balloon per second. It doesn't have to be, but I suppose it is. But that's not important. What is important is that they're going at a higher speed. That means higher momentum. Apparently you had to mention it. So I lost 2 marks there because there were 2 things they didn't ask for that I was supposed to mention. Wow, I lost 20 marks altogether. It's not because of my lack of knowledge, it's just because you don't know what they want. Oh my god. Oh, it's out of 100, thank goodness. I thought it was out of 80, so I got 80. I am not happy with that. Let's look up, so this is 2020, May 2020. Let's look up the grade boundaries. GCSE AQA 2020 grade boundaries. Grade boundaries, November 2020. No, not November 2020. May 2020. Oh no, November 2020 is when they collate them all together. Okay, fine. November 2020, so we've got physics. Tier H, maximum mark 200, grade 9 is 140. So you need to basically get on average 70 per paper. So we've already got 80 in the bag. So we need another 60 on the next paper. So 60%. That is achievable, right? So I think I'm okay. It wasn't that bad. I was actually above average, but still, I thought it was doing so bad. Oh, that was so annoying. That is the most annoying paper I've done so far. So many things that I was writing correct things, but just not what they're hoping for. Okay, that just goes to show you. You have to just write and write and write, because you can't be penalized for writing lots of stuff. I had 10 minutes left, say 12, 13 minutes left. I should have just written more stuff. Because, you might, if you just write more bullet points, you can't be penalized for writing additional things unless they're contradictory, but that's, like, just be smart about it. But yeah, just write everything that comes to mind. Just keep writing bullet points, even if they ask for 3, put more. Unless you think they're going to penalize you for putting more. Sometimes they do. Yeah, that paper, I would say, was the most punishing towards people who know the material, i.e. physicists, but don't know the GCSE style of answering questions. This was all about the style. This is where I lost marks. I wasn't trained in the art of knowing what they want you to put. You don't necessarily put the right answer. You put what they want to see. This paper exhibited that effect the most out of all the papers I've done so far. Okay, well, enough complaining. I got a good grade, so I'm not going to fail in life. I'm still going to get a job, he says, while unemployed. So paper 2 will be also 1 hour 45. I'll probably do that tomorrow or the day after. That'll be physics done. And then after that, we could get onto the really boring ones. Oh, what shall I do after that? Electronics? That'll be interesting. I'm not looking forward to chemistry because I don't remember any of that stuff. All I can do is sing the song. Oh no, I forgot the song. There's antimony, arsenic, aluminium, and selenium, and hydrogen. Yeah, okay. No, don't sing it yet. We'll sing it when the time is right, when I get to chemistry. All right, well, thanks for watching.